as we mentioned earlier on, the binomial theorem is a formula to help us do the binomial expansion. Okay, so here we are, the formula. Okay, now it may look very intimidating, okay, for first time learner. Okay, and of course if your first time is seeing this, you go, whoa, what is this formula? Okay, now it looks difficult. Okay, it looks difficult, but it's actually not that difficult. Okay, now here, what I have here, alright, for you is three different ways of presenting the binomial expansion. The three different ways, but they're all representing the same thing. They're all the binomial theorem. So let's take a look at one by one, okay, one after another, to see what's going on here. So this is the binomial expansion raised to the power of n. Okay, so n is an unknown number, okay, positive integer. So how do we expand this? Well, these numbers here, nc0, nc1, and nc2, nc3, and so on and so forth, these numbers here are known as the binomial coefficients, okay, which we earlier talked about in the Pascal's triangle. We can actually get these coefficients, okay, using the Pascal's triangle. But of course, as we mentioned earlier on as well, that to use the Pascal triangle to do a binomial expansion of higher powers, it's really quite tedious. Okay, we've got to construct a triangle to say power 10, and then I think it's really not worth the time. Okay, so of course we have a better way to help us find what is nc0, nc1, all these binomial coefficients. Okay, so let's put aside the binomial coefficients first and take a look at how the formula works. Now this is the first term in the binomial expansion, okay, a, and the second term b, right? There must be two, right? So a and b. So what happens here is this, alright, in the expansion, the first term, alright, which is a, will have the full power n, while b has 0 power. Okay, now as we move on to the next term, a will lose 1 power, while b will gain 1 power. Okay, now b has power 1. Alright, as we move on to the next term, as you can see very clearly now that a loses 1 more power and b gains 1 more power. Okay, now this relationship will go on. Okay, will go on. A will continue losing 1 power, and b will continue gaining 1 power, and so on and so forth until the last term, where a has got no more power, 0. Okay, and of course b will have the full power n. Okay, so this is how we do our binomial expansion using the binomial theorem. This is the formula itself. Now the next question that you must have been asking will be, okay, this sounds easy. I mean, a has got full powers, and slowly it's transfer the power from a to b, and lastly b will have the full power. But how am I going to find the nc0 and nc1 and nc2? Well, very simple. Look at your calculator. Okay, you have in your calculator this function, ncr function. Okay, so we will use the calculator to help us calculate the binomial coefficients. Alright, now next we will move on to the next second version of this same formula. Alright, there's actually nothing different. The only thing different is the nc0 and nc1, the binomial coefficients. But basically in some textbooks, as you will see, some textbooks write nc0 as n0 in this column vector form. Okay, so this is actually nc0, this is actually nc1, this is actually nc2, this is actually nc3. They are the same, so do not be intimidated by the look of it. Okay, if you happen to see this in another textbook, well, they mean the same thing. Let's move on to the third version of the same formula. Okay, this is so what is going on here. Very simple. nc0 is always 1. Okay, now if you remember what we mentioned about in the Pascal's triangle, the first number in the Pascal triangle is always 1. The last number is always a 1. Okay, starts with a 1, ends with a 1. So this is the first coefficient, and therefore it's always a 1. Even if your n is 10, 10c0 is 1. 100C0 is still 1. Okay, so the first coefficient, the first binomial coefficient is always a 1. Alright, likewise the last one is always a 1. So in this case we really don't have to write down NC0, okay, because we must know that NC0 is a 1. Now, and of course b to the power of 0 is also a 1. Okay, as you will learn in the law of indices, that any number raised to the power of 0 is 1. So 1 multiplied by 1 multiplied by a to the power n is obviously a to the power n. Okay, the 1 basically is not important, alright, insignificant there. Okay, that goes to say that it's the same for the last term. Okay, NCN is a 1 and a to the power of 0 is also a 1, and therefore we only have the last term as b to the power of n, and of course everything in between remains the same as what we have talked about earlier on in this example. So this is what the binomial theorem looks like. Okay, and of course in the next example, the first example, we will use the binomial theorem to help us expand a binomial expansion.